Good morning, team, and thanks again for your time. My name is Mohit Nair. I'm a partner technology lead. I manage the technology aspect of Google Partner Alliance, and I work with various global and regional partners across India. I joined Google around an year back, and before that, I worked with Microsoft for a really long time in various technology and consulting oriented roles. And today, for the next 20 minutes, I will cover the GCP application modernization story, and later on, the CS team will also have a detailed hands on session on this front. So let's start with why Google Cloud, right? Simple question. And if I have to summarize this in one slide, given the time constraints that we have, then I would like to cover these points. So the first is security. As you all know, security is the most important factor that enterprises consider for cloud migration. And in this regard, if you want to leverage a platform where your data is 100% encrypted, then GCP is for you. That's the right choice for you. We are the only CSP, I repeat, we are the only CSP where your data is encrypted by default with multiple options to manage the encryption keys. By default, we manage the keys. We also allow our customers to manage the keys. And not only that, but customers can bring their own keys as well. That means even Google can't look into this encrypted data. Not just that, but we deliver end-to-end secure solutions from the data centers all the way to the devices using a purpose-built infrastructure with multi-layered defense in depth, secure environment, and trust nothing approach. On the security front, our messaging is very simple. You own your data and not Google. It's a shared responsibility model. We never share customer data with third parties. Neither do we use the same for advertising. Not only that, we never give any backdoor access to any government for your data. We are also proud of our certification and compliance across geographies and industries, from ISO to SOC to HIPAA to GDPR and many more. Not only security, but we are the only CSP where network is a global resource. That means a VM deployed in US Central can communicate with another VM deployed in Bombay, where we have our data centers on Google's internal network using internal IP. Consider latency, performance, and security. And that includes thousands of miles of Google-owned fiber optic, making it the largest private network in the world. On the scalable infrastructure front, there are only 13 products in this world with over a billion monthly active users each. 9 of them are owned by Google that you use on a day-to-day basis and trust. I'm talking about Google Search, Gmail, Map, YouTube, Android, Chrome, Photos, and many more. And now we want to partner with our customers so that you can leverage the same underlying infrastructure that Google runs as billion user products for your enterprise solutions. On the data analytics front, if you are looking to leverage a petabyte scale, fully managed serverless data warehouse, that means you don't need to provision, configure, monitor, or tune, which allows real-time streaming insights with built-in machine learning capability just by using SQL. That means no need to learn anything fancy like Java or Python and an in-memory BI engine, then GCP Cloud has a solution for you. If you are looking for a true hybrid and multi-cloud open source solutions without any lock-in in terms of software as well as hardware, then which can be deployed in hours and not months, and that too on a cloud and not co-location facility, then GCP is for you. That offering is Anthos that provides a single pane of glass to manage your containerized workloads across on-premise, GCP, AWS, as well as Azure. In the infrastructure modernization space, we will go deep into this one. We believe that you know your application best, right? So we will let you decide what you need instead of forcing you to fit in your solution on a predefined VM in terms of CPU and memory. Let's say if you need 6 or 12 vCPUs, that's absolutely fine. You don't need to have 8 or 16, and the same stands true for the memory as well. And that to pay per second. And that's precisely what a custom VM is. You decide what you need and save up to 70% without any upfront payment. GCP is the platform for you, if you want to leverage the same infrastructure that SAP uses for its S/4HANA product development with over 10,000 developers in Germany. If you're looking for a certified SAP VMs, which could be predefined or customized for your business needs, then GCP has the right solution for you. Not only that, if you would like to leverage Google's engineering capability, the same capability that we are famous for, to minimize downtime for your mission critical workloads by using live migration, then GCP is the right choice for you. And last on this slide, if you want to experience the power and simplicity of your favorite product, that's Google search for your business, then GCP has a solution for you. So that's in nutshell, literally in one slide, what why GCP. And not only me, as a Googler articulating our value proposition, but what's most reputed organizations also have to, say the same. GCP is the leader, and not only in 1, 2, 5, or 10, but in 22 areas across infrastructure, data, analytics, security, networking, AI, ML, application development, big data, and many more. Just to share some customer credentials, our customer focused approach and value engineering has led to phenomenal progress for GCP across industries. We already have an incredibly strong presence in many of the leading institutions around the world. These are some of the customers using Google Cloud to run their business. Again, this is a limited set of Indian customers that we have recently worked with, right from Tata Steel to Z to Hero and many more. Not to mention some of the largest financial institutions run their workload on GCP. I'm talking about mission critical workloads. I'm talking about likes of ICIC, HSBC, HDFC, XR, Prudential, and Karur Vysya Bank. In the application modernization space, we have solutions covering all aspects of compute, starting from compute engine in infrastructure as a service space, where we are the only CSP with custom VS, as I just covered, as well as certified SAP machines, that to pay per second, and you can get sustained usage discounts, that is discount without any commitment, or you can get 70% up to committed usage discounts without any upfront payment. If you're looking for enterprise ready containerized solutions with pre-built deployment templates, which will help you with portability, simplified licensing, and consolidated billing, then GK is the solution for you. In the same space, you also have Cloud Run, which is a fully managed compute platform that automatically scales your stateless container. Cloud Run is serverless. It abstracts away all the infrastructure management so that you can focus on what matters most, which is building great applications. With App Engine, you can build and deploy applications on a fully managed platform. Scale your applications seamlessly from 0 to planet scale without having to worry about managing the underlying infrastructure. With zero server management and zero configuration deployment, developers can focus on building great applications without the management overhead. That's the beauty of the solution. On the function as a service front, Cloud Functions is GCP's event-driven serverless compute platform. Cloud Functions, scales ups and downs, so you pay only for the compute resources that you use with no servers to provision, manage, or upgrade, along with automatically scaling based on your load. Cloud Functions has a simple and very intuitive developer experience. You just write your code and let Google Cloud handle the operational infrastructure. With this, you can develop faster by writing and running small code snippets that respond to events. So that's what Cloud Functions is all about. Not only that, but on the ML API front, we offer tools that make it easier for developers to add site, language, conversational, and structured data capabilities to your applications. Guys, can you go on mute, please? Let's go a little deep into what we have in the infrastructure modernization space. I love my country, and we know that we have a price conscious market. So let's start with that. On average, GCP enables customers to save up to 60%. How do we do that? Is by leveraging a mix of three things: list price differences, sustained usage discounts, and custom VMs. Let's start with custom VMs. Just to reiterate, as we just covered, we know that you know your application best. Our customers know their application best. So we let you decide what you need instead of forcing you to use a predefined VMs in terms of CPU and memory. That's what custom VM is. On sustained usage discounts, we have seen an average of 24% savings, which can go up to 30% by doing absolutely nothing, like signing a different contract, clicking a button, nothing of that sort. Just keep on using the machine. The more you use, the better the discount will be. On committed usage discounts, if you proceed with 1 or 3 year commitment, That can result in up to 70% discount without any upfront payment. We also offer preemptible VMs like spot instances, but without the hurdle of bidding, which can result up to 80% cheaper. Not to mention, we are the only CSP that offers right sizing recommendation, where we will let you know if you are not using your machine optimally and if there is an opportunity to save cost or increase performance. We also offer live migration. So in event of host restart due to patching or any other reason, we will migrate your VM to a new host, including moving the content of RAM to minimize downtime. Very, very useful for critical SAP workloads. So I was saying, with right sizing recommendations, we help you optimize the resource utilization of your VM and save cost. We will let you know if you are not making best use of the machine, that you have provisions by looking into the last 8 days of usage and accordingly show you notification where you will get an option to resize the instance type and save cost. That's how simple it is at a VM level. We will also let you know, if you have high utilization and if it will be helpful to scale up the instance for faster computation. We do that as well. So we cover both sides. So upfront, you can decide what you need with custom VMs, and then after deployment, you will be also able to save more by leveraging our right sizing recommendations. Thus, absolutely no need to over provision at all. That's how simple our solutions are. Again, just to share some customer credential, Schlumberger, the world's largest oilfield services company, they wanted to leverage the strengths offered by GCP platform for data processing capabilities. With GCP, now they have deployed over 10 petabyte of storage and over 35 petaflops of compute capacity to automate their 3D seismic interpretations. So that's the scale I'm talking about. We also understand that migration projects are often large and have lots of moving parts. So we are going to start by offering you a free discovery and assessment. We will assess what you have on premise and then see how all that maps to Google Cloud and what your proposed TCO or ROI models look like by migrating. And we are going to do that for free. So you have nothing to lose by exploring what you have and what it could look like in the Google Cloud. Connecting back to the cost optimization, our discovery and assessment tools, they produce details on how much is your current utilization, including 95 or 99 percentile, along with associated cost of running this solution on premise, and how much you'll be able to save when you move to GCP using a no commitment model or a 1 or 3 year commitment model. So what it will look like in Google Cloud with multiple pricing options. You will have all the options. So let's say you have just 10% of utilization, right? You don't need to have this large machine on premise, right? No need to over provision at all. And using our assessment tool, we will suggest what is the best matching VM based on your application needs and respective utilization. So in this example, you will be able to save over 90%. Not to mention, you will also experience the agility, cost, and performance benefits offered by Google Cloud. And what you have to pay for this? Absolutely nothing. You have nothing to lose here. I repeat. And we have agentless solutions. So we don't even install anything on your VMs. So you have nothing to lose from a cost perspective, nothing to lose from a security perspective. Agentless, that means we will just pull the data through the hypervisor or through probes. We will not install anything on your VM from the security perspective. So you are covered from all aspects of solution. Again, we all know application development is not complete without data storage, and GCP delivers various storage service offerings that remove much of the burden of building and managing storage and infrastructure. Our storage offerings range from SQL to NoSQL, blob storage, depending on what you're trying to do, right? And it's very easy to mix and match as well. So let's say Cloud SQL, which gives you the fully managed MySQL, Postgres, as well as SQL Server. So you have relational database, right, and a more traditional approach to queries. We also offer Cloud Spanner, which is the first scalable enterprise-grade, globally distributed and strongly consistent database service built to specifically combine the benefits of traditional relational database structure with non-relational horizontal scale with an industry leading 5 nines of availability SLA. So that's the beauty of the solutions with no planned downtime and enterprise grade security. Cloud Data Store provides a nearly infinitely scalable schemaless solution. For just pure data and blobs, cloud storage can deliver what you need. Cloud Bigtable, offers a fast, fully managed, infinitely scalable NoSQL database service, ideal for web, mobile, and IoT applications. And we have briefly covered BigQuery. So again, BigQuery is a petabyte scale, fully managed serverless data warehouse platform that allows real-time streaming inside using SQL. It has built-in ML capability along with a built-in memory engine. BigQuery stores data in a compressed encrypted columnar structure, right? And it doesn't use or support indexes. That's a big thing, right? So you don't need to worry about index tuning, fragmentation, or rebuilding. Without that, it works just fine. BigQuery has decoupled storage and compute from the maximum flexibility. It supports automated data transfer. That means you don't need to write ETL packages, and that too in real time. It has federated query support as well. That means multiple compute options, right? Let's say your Hadoop cluster and BigQuery can leverage the same set of data without making copies, as well as flexible pricing, right? We have two models, pay as you go or monthly flat rate. Not only that, we also offer flat 50% discount on long-term storage. That's a lot of discount I'm talking about if you don't change your data in last 90 days, which is typical for a warehouse solution. So in nutshell, with streaming capability and ML models right into the BigQuery, you can make data-driven decisions in real time by leveraging linear regression, binary and multi-class logistics model along with k-means clustering. And not only that, but you can also import pre-trained TensorFlow models in BigQuery. So that's how powerful our offerings on the data space. And as you need to manage the application as well, we offer operations suites, formerly Stackdriver, which is designed to monitor, troubleshoot, and improve the cloud infrastructure software and application performance. You can collect signals across GCP internal and external hosted applications, including platforms and services, and then analyze and visualize those signals. You can also set up appropriate performance and availability indicators, and you can use built-in observability to troubleshoot and improve your applications. Stackdriver covers everything, right? Right from capturing signals to monitor the system, setting up alerts, and troubleshooting issues like logging, monitoring, cloud debugging, profiler, trace, and error reporting, which are all part of Stackdriver. On the containers front, in Google, from Gmail to YouTube to search, everything runs under the containers, right? Each week we start over billion containers, and we have learned a lot about running containerized workload in production for over 10 plus years. On a multi and hybrid cloud front, Kubernetes was born from the tools that we developed to manage our own infrastructure and computing environment. In essence, customers have been asking us for a different type of hybrid and multi-cloud. They don't necessarily see hybrid as physically rolling in hardware with proprietary stacks into their data centers. They see hybrid as software-based, running on their existing hardware, built on open standards, and built to abstract away the infrastructure instead of locking them in, right? And that's exactly what we offer. And that is Anthos, which enables choice to run your workload anywhere you want without any lock-in. So Anthos lets you build, deploy, and manage applications anywhere in a secure, consistent manner. Anthos provides a single pane of glass to manage your containerized workloads across on-premise, GCP, AWS, as well as Azure. So it doesn't matter where you run your workloads, but you can manage the same with GCP in terms of policy, service, and cluster management.
So here is a tech series on Google Cloud Platform. I'm going to touch base on a few important topics that I think ought to be covered here. So I am specifically going to get into GKE, some best practices surrounding how to set up a GKE cluster, how to use a GKE cluster, what are the various features available on it, how to leverage these features. I'm going to talk a little bit about CI/CD also on Kubernetes. And while I'm talking about GKE, I'll also side by side, I have a console, a sandbox environment ready where I'll be walking you through what the cluster setup looks like, what kind of features you can expect, what boxes you should be checking and what you should not be checking. And I'll cover the CI/CD as a part as well, but I think that will be a little more theoretical. So to introduce myself, I am a lead cloud architect at Searce. I'm certified on both AWS and GCP. And So let me just dig right into the presentation, right? So we're going to start off with best practices for GKE. And I'm already assuming that everyone on the session has at least some level of knowledge about Kubernetes, at least at a conceptual level. But despite that, I'm just to make sure I'm covering all my bases. I'll go ahead and elaborate a bit on what is Kubernetes. So, what is Kubernetes engine? So, before Kubernetes was Kubernetes, it was just an open source cluster management tool. It was a internal cluster management tool used by Google, for services like Gmail and their other internal workloads. And they had labeled it Borg. So if there are any Star Trek fans out there, you'll immediately recognize the analogy that they're making here. So Borg is supposed to be a hive mind, which is a very apt name for this cluster management system that they came up with. And it wasn't until several years ago that they decided to open source this project and make it available to the public. And they renamed it as Kubernetes, which means helmsman in Greek, right, or pilot. And this tool has actually revolutionized the container management world, right? Because up until now, microservices did exist, containers did exist, but the orchestration and management of these containers was a very tedious task. And Kubernetes served that purpose brilliantly. But there were some challenges in Kubernetes as well, and there still are to this day in unmanaged Kubernetes. So eventually Google came out with Google Kubernetes engine, right? But what was the reasoning behind GKE? What is the difference between GKE and Kubernetes? Well, Kubernetes in itself is an unmanaged open source cluster orchestration solution. But there are certain challenges. So if there are any DevOps folks out there, right, who've worked on unmanaged Kubernetes clusters, I have had my fair share of experience with unmanaged Kubernetes environments, and at the least, they are a very cumbersome baby to actually take care of, because you get calls at 2 a.m. at night with these alert calls. Perhaps some pod is not being scheduled on node for some reason. Maybe a node upgrade is required. Maybe some patches are required, and all these kind of overhead management tasks that normally we should not be wanting to get into, but we have no choice because that's just the way the infra was set up. And to address all these challenges, right, that Kubernetes brings about for a DevOps person's life, they introduced GKE. And GKE is built with the similar mindset that the entire GCP platform was built, right? If you look at something, perhaps during Mohit's presentations, that you'll identify one feature in common among all the various different resources available on Google. Google is clearly identifying an intent to make the developer's life as easy as possible. The entire infrastructure management, they are trying to abstract that overhead away from their customers and from their users. They want you guys to focus on your application, put out the best application that you have, focus on development, focus on putting out feature updates, those kind of things. Worrying about the infrastructure is actually supposed to be it should be a secondary priority. But in today's world, we find that it's actually becoming a primary priority because of the way applications scale in today's world. And that's where GKE comes in, right? So GKE has everything that Kubernetes doesn't, right? The entire master node is abstracted and managed for you. The entire control plane is managed for you, while at the same time giving you a surprising amount of available customizations. So features such as load balancing and auto scaling of the cluster, right? And the automatic repairing of nodes, the automatic upgrades. These are all features that GKE provides. And frankly speaking, Google Cloud is not the most mature CSP out there. They came a little late to the market, right? AWS and Azure have been there for a while before that. But of all their products, I think GKE outperforms any other cloud service providers equivalent Kubernetes solution. By miles, that too, right? Because GKE was actually put out much before the other Kubernetes services, before EKS and AKS, and they've actually used their inherent knowledge about the Kubernetes ecosystem to create this product, right, and fine-tune it in such a way that it makes the application user very, very satisfied. So I'm going to talk you through a bit about what kind of features you can expect from GKE, what you should be using, what you might not want to be using. Right, and the reason I'm bringing all of this up is because I have had countless customer interactions, right? And I've seen production environments where people develop they deploy their GKE or their Kubernetes environment, and they leave all the settings on in default, and because they're not aware of what does what, right? And because of that, it causes a lot of challenges in the future, especially when they start to scale with that kind of infra, right? They won't notice any problems in the beginning because they've gone for all the default settings, right? It's meant to uh, not break in the beginning. But when you scale up, right, and it becomes a lot more challenging to actually adjust your infra in such a way that, to undo the changes that you've made. So I'm going to teach you how to actually set up your GK environment and how to use it properly so that we can actually go ahead and implement this in our real life world. So a few facts about GKE, right? It's reliable, it's secure, it's agile. And one component here that I feel is missing is it has a very good performance actually. Like it's standing on Google's infrastructure, right, and Google's networking. So the performance is also actually very good compared to the other Kubernetes services out there. So let me talk about some of the features that you get, right? Node auto upgrades. So this is a feature that GK allows you to enable, right? And it's going to be enabled by default in a later version of GKE. But basically, the simplest thing you can do to actually ensure that your cluster is secure is by regularly upgrading your nodes. So GK can entirely abstract that feature from you, right? You can manage the upgrades by itself. You can even provide your own maintenance window to say that, okay, if any updates are happening, I want it to happen within this time frame, right? If you do not choose to enable this option, then it's highly recommended that you at least upgrade your nodes at least once a month, right, for optimal security. Node auto repair. This is an amazing feature that GKE has. So as soon as a node is unhealthy or unreachable, GKE will restart that node and or replace that node with a healthy node, right, until it starts passing the health checks. And this is great, especially when you're using preemptible virtual machines, which is the equivalent of spot instances, somewhat, not to be too blunt about that, but so if you're using machines which are not really fault tolerant, right, if you know that these nodes are going to fail every now and then, or you're worried about zonal failure, right? So this GK actually has this node auto repair feature where it recreates unhealthy nodes for you, which is a very useful feature to have. And unhealthy nodes have it's very gracefully terminated, right? They pause the drain first, it's cordoned, they pause the drain, and then the node is recreated. And then we move on to cluster autoscaler. So cluster autoscaler actually, it allows you to autoscale your node pools, right? You can set a min value and max value. And this autoscaler is actually very intelligent. The GK autoscaler, it has a good amount of intelligence in it. Right? It's not just this blind autoscaling tool that's just going to look at the CPU metrics. When it reaches a threshold, it scales up, right? There's so much more to it than that. It has an intelligence to actually scale up based on cost. So if I have two node pools, right, node pool A and node pool B, and node pool B is a relatively cheaper node pool, they have cheaper nodes, right? So whenever the cluster autoscaler is making a decision to scale, it will always choose to scale the cheapest workloads first before going ahead and scaling the relatively expensive workloads. So we can actually take advantage of this and through various techniques, right, including through node pool shifting and stuff. You can also use the cluster autoscaler to balance across zones. So GK actually offers regional clusters, and when you have a regional cluster, you have your slaves distributed across multiple zones in a single region, but you also have your master distributed across multiple zones. And this is done for multiple different purposes, right? You get a better response time when you interact with a Kube API server. You get the better high availability and reliability. So even in the worst case scenario where an entire zone goes down, say through some natural disaster or whatever it might be, right, you will have your master up in another zone, because if the master goes down, pretty much your cluster environment is pretty screwed, right? If your master goes down, then there's nothing left for you to do. It's just the nodes are going to be managing on whatever pods they have, right? Any other operations that need to be made will be problematic. So if you want to avoid this issue, you can always go for a regional cluster, and the autoscaler is always going to balance across zones. So let me show you what the console looks like. So when I create my cluster, right, I get various different options. So you can see from the left side how it's been segregated. So I can choose right here if I want my cluster to be regional or zonal, right? Do I want the master and the nodes to be and the slaves to be replicated across multiple zones or a single zone? I can also choose to go for the static Kubernetes version release or the release channel. I can I have various options when I'm choosing my version of Kubernetes. And here I'm choosing my master version. And then we go to the actual node pool configuration, which personally I think is probably one of the most important parts, right? You can add multiple node pools by clicking this button. And here you just enables auto scaling feature, and you can specify the minimum and max. And you can even set your minimum to 0, by the way. Your node pool can scale down to 0 if you have that kind of batch workload, which you just want to run, like, say, on a daily basis or an hourly basis, right? So this is something that Kubernetes can do. And you can see by default, these auto upgrade and auto repair features are enabled. And I was talking about horizontal pod autoscaling. So let me show you just how simple it is to perform horizontal pod autoscaling in GKE. So in my demo cluster, right? So I've created this cluster just for this session. I can see I have a small Nginx deployment, right? So personally, I am a fan of CLI. Every time I need to make some changes to the Kubernetes environment, I always use this command line. But lately, I've been actually getting into the Google UI, and I realize it's actually very, very user-friendly and very simple, very straightforward. So instead of writing a YAML file for the HPA, right, I can just click on this autoscale button, and I can specify my min value, my max value. I can choose my scaling metric. I can choose my target threshold, and I can even add multiple metrics, right? And once that's done, I just click on autoscale, and that's it. Then my deployment autoscales based on that information. I can also choose to scale my replica directly like that. I can just click on the scale button. I can expose my I think I've scaled it already. Oops. Anyways, I can put out rolling updates. I can expose it via a service, right? So I can even create a service just by using the user interface. I don't even need to create a YAML file for that, which is pretty impressive to say the least, right? So that's a bit about the horizontal pod autoscale. This is a normal feature, right? This is not unique to GKE. This is a Kubernetes feature that you will find on any Kubernetes environment. The thing is, this actually relies a lot on your cluster autoscaler. So your cluster autoscaler needs to scale quickly, and GK's cluster autoscaler actually does a very good job at scaling nodes, right? You'll notice that the entire Kubernetes environment itself gets spun up in like a few minutes, right? So that should tell you a bit about what kind of scaling they're doing. And here we move on to VPA, vertical pod autoscaler. So now Kubernetes has recently released this feature for vertical pod autoscaling. So what is vertical pod autoscaling? Well, it's exactly what it sounds like. Instead of scaling your pod by increasing the number of replicas, it actually increases the resource requests and the resource limits for that particular pod so that it can actually scale up within its host node, right? But there is a hidden feature to this, which is actually also very useful. So even if you're not interested in using the VPA, and the caveat here is the VPA and the HPA, they don't usually go in tandem, right? If you are using both of them, then what you want to do is you want to use different scaling metrics. So if you're using the CPU as a scaling metric for HPA, and then you're using the CPU again as a scaling metric for the VPA, right, you're going to have a lot of problems. You're gonna have to use totally different metrics, right? For the HPA, you might want to use requests per second instead. But so let me show you this. So there's this feature it has that it can actually make recommendations on your container specification. So a lot of customers that I've dealt with, right, when they're creating a deployment, they look at the deployment file. They're like, Alfred, so I've set this resource request and limit, and I ask them, okay, so how did you set this value? This number of CPU and this number of RAM. And they always say, oh, I just saw it online. These were the default options, so I just set it as that. And then the follow-up question is, but does your application actually require that much, or does it require lesser or more? And they're like, I have no idea. And that's fair. It's tough to actually gather that metric, but not anymore, right? Now we have this VPA. So I've enabled, if you look at my deployment, right, I just have this single deployment up and running, an Nginx deployment, and I've enabled VPA on this. So if I do I set up a VPA called my VPA for this Nginx deployment, and if I show you, so now I'm just doing a OYAML on the VPA, and if I look at below the status, right, I can see this parameter called recommendation. So in this recommendation, it's actually showing you for my container. Right now, there's just one container. If your pod has multiple containers, it'll show for all the containers, right? So it's actually giving me container recommendation. So it's telling me that at a minimum, my lower bound, I require 25 milli CPUs and around 26 MB of RAM, right? And at a maximum, I would require this much. Now, do keep in mind that this test is this recommendation is only effective if you are simulating a load while checking the recommendation. Right now, this is just a normal deployment with no load on it at all. So these recommendations might be a little deceptive. But if you perform this VPA recommendation while you are actually doing a kind of small load test, or even if your application is in production environment, right, it will actually give you the recommendations that you require. And all I need to do is I need to change this from off to on, and that actually enables the VPA. So right now, all I'm doing is I'm just collecting the recommendations that I want. If I want to actually enable the VPA, if I actually want the VPA to take action based on these metrics, right, then all these recommendations, then I can just change this to update mode to on, and the pod will start, vertically scaling. So that's another really cool feature that it's there in Gkey, and this feature actually works very well with another feature that I'll cover in a bit, which is node auto provisioning. So node auto provisioning is, again, these are, I think it's saying beta on the top, but these are, I think these slides are a little older. They are in general DA right now, so it's available for use. And node auto provision is already something that we are using in some production environments. So what is node auto provisioning, right? So basically, this is, you can think of it as a safety net for your autoscaler, right? So I'll show you exactly how it works. Basically, Google creates a new node pool for you, right? And the new node pool, the size of the new node pool is entirely dependent on the kind of workload that you have. So say your autoscaling limit is from 1 to 3, right? And you need to scale up beyond that, or you don't even have autoscaling enabled, right? In that case, node auto provisioning will actually provision an entirely different node pool. And say you have a new pod that doesn't fit into any of your existing nodes, right? What this new pod can do, what the auto provisioning can do, is actually provision a node which is very apt in size according to the pod's requirement. So if you have a very large pod, you're going to notice that NAP is provisioning a much bigger machine, or much bigger size node pool. And if you're scaling up a smaller pod, the NAP will provision a smaller node pool size. So right now I have just 2 nodes in my cluster, each of them with 1 vCPU each, right? And I'm going to scale up this workload. So I'm going to use the same deployment here. So again, use the CLI, but I'm just going to, so what I'm going to do is I'm going to scale up this deployment, right? And if you can see my cluster, right, I have, I don't think I've enabled autoscaling. So autoscaling is off. Yeah, so autoscaling is off, and I just have 2 number of nodes, right? And node auto provisioning is enabled. So basically, node auto provisioning is going to guarantee that my workloads are being provisioned somewhere, right? So let's see what happens when I scale. So I'm just going to scale this to say 7 replicas, 8, nice even number. And so immediately I can see, right, the pods are unschedulable and does not have minimum availability, right? Because these 2 pods are fine. It's just that the additional pods, right, they have no place to go. So if I check my node pool, let me see if I've enabled NAP. Oh, okay, let me just increase this a bit more. Actually, let's leave it at that. Let me scale a little slower. But anyway, so since I initiated the scaling process, right, what you can already see is happening is that a new node pool has been created for me. It's called, and this is the default name, which is given NAP N1 standard 1. And if I look at the machine type, right, it's N1 standard 1. So why is it N1 standard 1? The reason that the machine has been chosen as N1 standard 1 is because I'm scaling up a very small pod, right? My workload is not very large. If my workload is much larger, you'd see that this new node pool will have a much bigger machine size. And eventually, if I just keep doing now I can see, right, before my containers were like in pending stage, now they're starting to create. And the reason it might takes a couple of minutes to create is because I've kept a startup script in these pods to show you something else in the future. But that's the power of node auto provisioning, right? So even if you are reached the thresholds of your scaling limits, right, there's always a 1 step higher that you can go, right? This is your safety net, right? If anytime you go beyond your peak traffic or beyond your expected traffic, right, node auto provisioning can actually take care of your workloads, and it scales very efficiently. If you notice, like, it's not creating a very large node pool, right? So if I had created, if my default node pool was say 8 cores and 32 GB in RAM, right? It would still create this N1 standard one machine, because this N1 standard one machine is actually more appropriate to the pod specification. So rather than wasting your resources and money by creating an entire new node with 8 cores and 60 GB RAM and 30 GB RAM, it's creating a smaller node just to accommodate the extra load, right? And that's the way you want to scale. Actually, you want to accommodate for scale. You don't want to over provision here. So yeah, that's a really neat feature that you have. And moving on, we have container native load balancing. So I'll tell you the difference between what some people might wonder, like, why does GK usually perform better than the other clouds? I mean, it's not just talk, right? I'm not one to actually be biased towards any cloud provider. For me, it's all about the technology. And here, if you can see, let's see how they handle the load balancing. So you can see, firstly, to get container native load balancing, you need to enable your alias IP addresses. But once you do that, right? So the traditional approach of communicating to pods via the load balancer is, the load balancer gets a request, right? It sends it to the instance group. The instance group then sends the request to the node or the instance within its group. The node then actually checks its IP tables for the list of pods within that is the list of pod IP ranges that are there, and then it redirects the traffic to the respective pod IP range. But this is just from me explaining this process, you can see that there are several hops that are going into this, right? Isn't there a better way to do this? Isn't there a faster way to do this? And there is. So there's something called a network endpoint group. You can actually serve your services, right, as network endpoint group. So the load balance is directly going to hit a network endpoint group, and the network endpoint group directly has access to the pods that are there. There's no IP table checking, right? So this direct communication actually actually reduces the backend latency considerably. And that's how GK actually manages to get, this is one of the reasons why GK manages to perform better, right? Because the traffic is flowing a lot faster within its network. There are no redundant hops. There are no, it's all direct communication, right? So that's assuming you enable this network endpoint group option. So this can be done by just annotating your service with a certain tag. You have to enable alias IP ranges and then annotate your service with a certain tag. And now I'm going to talk a bit about security on GK. So GK has a lot of security features. Like, we have deployed GK for several fintech and several compliance-heavy customers, and the reason being is because it has a lot of options for maintaining your security, right? When it comes to IAM, identity and access management, choosing the right container images, having shielded nodes, restricting network traffic, having the ability to create a private cluster. There are cloud providers out there which don't even have this option of creating a private cluster. I mean, you think about it, such a desperately needed feature that ought to be there, right? If you're anywhere in the industry of security, right, private cluster is absolutely essential. It has Cloud Armor, which acts like it's a L7 and L4 and L3 DDoS protection, as well as it serves also as a WAF, right? And you can apply this on your GKE backends. You can implement network policy. So either you can use like open source STO, or you can use Google's, they're using Project Calico to enforce the network policies. They've partnered with Tigera to actually use Project Calico to enforce these network policies. And you can think of network policies as kind of like, firewall rules between pods, just making sure these pods cannot communicate to those pods and vice versa. And vulnerability scanning. So the GCR, the repository where you actually store your images, right? Without you have, so I think Mohit was talking a bit about security at default, right? So Google actually has a lot of security at default. I mean, even the etcd is encrypted by default. You can add an additional encryption layer on top of it, but a lot of things are already secure on GK, and one of them is including the GCR repository. So the repository where you are storing your container images, right? By default, it actually scans for image vulnerabilities, and it actually informs you, okay, this base image has a certain weakness or vulnerability here or there. It's a very useful feature. So now let me talk about private cluster, right? I talked about restricting network access. So there are three options available. And this is actually very important when you're creating your cluster, because whenever I see most people create their GK cluster, they always select the first option, and it just pisses me off, right? So the first option is actually the least restrictive option, and each of these points are in ascending order of restrictiveness. So the first option, right, public endpoint access disabled. So what is the public endpoint that we're talking about? Here we're talking about the master API server, the place where you actually go to make kubectl commands. So every time you run a kubectl command, right? Every time I'm running a kubectl command, it's interacting with the master API server. And in this case, your master API server has a public IP endpoint, it's an IPv4 address, and it has no IPs whitelisted, meaning anyone who's authenticated with your cluster can interact with your Kube API server from pretty much anywhere. I can sit in Mexico and run a kubectl command as long as I'm authenticated with your cluster, right? And that's a very dangerous precedent to set. And the second option is slightly more secure, right? It's saying, okay, I'm going to leave the public endpoint. I'm going to keep a public IP on my master API server. But on top of that, I'm going to also whitelist certain IP address ranges, right? That's called master authorized networks enabled. So you whitelist certain IP address ranges, and only those address ranges can interact with your public IP endpoint. Now, again, this is the recommended option in quotes, right? The Google recommend option, but personally, I don't recommend this option because unless you have that kind of requirement where you have a SaaS kind of CI/CD and you need a public interface for your GK cluster, I don't think it's a good option because there are workarounds to attack this kind of environment, with IP spoofing and whatnot. The better option and the most restrictive and secure option is actually the last option, which is public endpoint access. I see. I'm entirely sorry. You can ignore the points. I mean, I was reading it in the opposite order, but the first point is actually the most secure. So uh, let me reiterate. So the last and the most secure option is basically keeping only a private IP endpoint. So you won't have a public IP endpoint. You'll only have a private IP endpoint on your master API server. On top of that, you're also restricting, also whitelisting IP ranges for that private master IP. So if I have a VPN set up on-prem, right, I can whitelist my on-prem machines via the VPN, and they can interact with my Kube API server, right? But it has to be within that network. It has to be communicable with the VPC environment in which GKE is. So that is the most secure option, right? You go for a private IP endpoint which is not accessible over internet, and on top of that, you whitelist certain IP address ranges. And these whitelisted ranges might be your local systems, it might be a bastion host, whatever it might be, it just should not be the internet, right? And another thing that I notice very often, like a big security concern, is when I look at GKE nodes, right? Like I see a lot of the GKE actually uses compute engine nodes, and each compute engine node has a service account associated with it, right? So if I just take a look at this other cluster here, I don't know who has created this cluster, but so I'm just going to take a look at it. I'm not sure what kind of configurations have been set on it, but if I look at the node pool, and let me just, yeah, so I can see that the service account that it's using is the default service account, right? And this is the compute engine default service account. Now, I'm wondering, what does that default service account have permissions to, right? Meaning, if anyone logs into any of these GKE nodes, they will get permissions which the default service account has. So let's see what the default service account has, right? So the compute engine default service account, it has, just go to IAM. Yeah, so this is the very first one. This is the compute engine default service account. And you can see it has a plethora of permissions, but these have mostly been added by us. The main permission which it actually has is editor by default. This has editor permission, project editor. That means that anyone who logs into any of these nodes will be able to make editor-like commands, right? I will be able to delete Cloud SQL instances. I'll be able to create and delete GCS buckets. That's a very dangerous precedent to set, right? If for any reason, right, your node has been compromised, right? That's a very dangerous option to set. So if you look at the cluster which I have created, and here you can see in my service account, I've kept a specific service account. And if I look at the service account, you can see only 4 permissions. And these are the only 4 permissions which are actually needed by GKE, right? Actually just needs the monitoring viewer permission, just needs the monitoring metric writer, logging log writer, and storage object viewer role. Okay, but so here's the thing, right? What if you have a pod that needs to talk to Cloud SQL? What if you have a pod that needs to talk to GCS bucket, right? in that case, what do I do then? How do I give permissions to the pod? And the answer is simple. You can use workload identity. So without having to actually over-privilege the entire node, right? Instead of giving every pod in that node a certain amount of access, what I can do is I can actually restrict my access to a specific pod or a specific deployment, and that's by using workload identity. So by using workload identity, so just to show you what it looks like. I'm just going to log into one of these. If I look at my hope you all can see my screen, right? So if I look at my Nginx YAML file, right, I can see that the service account right now I'm using is a default service account. It's not even the default, some of them, okay, but doesn't matter. I'll fix that in a bit. So if I log into one of these pure pods, and I try to list, say, my GSU to my GCS bucket, right? I just need to do GSU to ls command. Right? Because of the lack of permissions right now, right? Oh, sorry. Let me choose a specific bucket. Let me try to copy, actually. I've given a viewer permission, right? So I'm going to try to copy. Okay, so I have a CSV file here, right? So I'm just going to do GSU CP. Oh, sorry, spelling mistake. Oh, my bad, my bad. I think I've overprivileged this. Sorry for that. I think I've overprivileged the service account. Basically, I think this is it's still using the old service account because I haven't updated it. But basically, I'm not going to show you now. It'll take some time, but you have to take my word for it. So basically, I made a typing error here, right? So it's still using the older service account. But if I just give it this default service account, right, and then I redeploy the pod, if I redeploy the pod and I run these commands, they won't work, right? But what I can do is, I have created a service account called bucket list SA. This is a Kubernetes service account. And what I have done is I have actually mapped the service account to a Google service account. So if I look at the Google service accounts and I have a bucket list SA here, right? This is a different service account. They have the same name, but they're different service accounts. And this service account has storage admin permission. It actually has the storage admin permission, which is currently there in the pod. So as soon as I change my service account over here, from the default service account to bucket list SA, right? And then I redeploy the application, then my pod will start being able to talk to the GK environment. Right now, I was testing it earlier, right? And I had left the correct service account there. The reason why it's actually responding like this is because the pod which I had logged into, it's still utilizing the correct service account, right? It's not using the default service account. But if I just fix that error, you note that even if I run this GSU till ls command, right? I won't be able to see all the buckets here. But once I add my service account and my service account has storage admin role, then I can do whatever I want to these buckets, right? Then I can log into the pod, I can interact with buckets. And you can use the same concept for adding any kind of permission, right? So here I've selected storage admin, but if I want to give my pod access to Cloud SQL, right? So I'll just give it SQL client permission, right? And that's how you actually use workload identity to provide permissions to various Google services. Sorry, the demo got a little messed up because I was not expecting the old service account to still be there. Made a bit of a typo on my end. But yeah, this definitely works, and this is something that I always use in every environment, right? In multiple production environments, especially when say I'm using proxy SQL, right? So if you want a proxy layer between your database and your application, you can use this kind of workload identity to make sure that only the proxy SQL pods have access to Cloud SQL. So even if someone logs into the same node where proxy SQL is hosted, they won't be able to make any communications to Cloud SQL, right? They will only be able to make communications if they are logged into that proxy SQL pod, which is the intention. So that's a bit about how you can use workload identity to restrict permissions to your cluster. So I talked about certain best practices on GKey, and if at all you want to learn more, or you're interested and you're curious about how you can actually leverage such features, right? Do feel free to reach out to me. We'll share our contact details or Searce at the end of this session. Let's move on to CI/CD, right? So uh, this is a very standard CI/CD approach on GKey, right? You have a source code repository, use container builder or cloud build, which is your CI in this case, to build the container image. Use GCR or the container registry to store the image, right? And then you can actually update the deployment of pod manifest or the Kubernetes manifests again in the source code repository, and those changes can be applied to your cluster through a CD tool, right? So here are some commonly used tools that we often use at Searce. So one is the source code repository, right? So you have multiple options here. You can either use the cloud source repository, which is Google's native CSR tool, or you can obviously use any of the open source options like GitHub or GitLab or Bitbucket, right? And then you have your CI environment. So my CI tool of choice is probably Jenkins, just because of the, even though it's an open source tool, it's not a native tool. I think purely because of the number of plugins and integrations it has, right? It's a very good tool. Even Circle CI is fairly decent that way. But Jenkins is open source and it's pretty easy to implement. And Jenkins is something that we often deploy on a GKE environment, right? So even your build, you want to actually keep your Jenkins in a separate node pool, or a separate cluster, your entire CIC in a separate cluster, and Jenkins in a separate node pool. So you can scale your builds separately, right? Your scaling of your builds should not impact your production environment at all. And then we have our container registry. So the container registry of choice here is GCR, right? And obviously you have other options like Docker Hub and S3, but GCR is actually a lot smoother to use, a lot more integrated, and of course it has that automatic vulnerability scanning, which is very useful. And of course, I think at this point, like a very, very powerful CD tool is Spinnaker, right? It's an open source tool created by Netflix. And this is actually, it works so well with, you can use it for multiple different CD options, but it works really well with Kubernetes, right? Especially like if you have these multi-cluster kind of deployments, right? Even if you have hybrid deployments, you have to deploy in multiple different cloud providers, right? Even then, Spinnaker is a really powerful tool, and it's a very efficient tool at that. So here's a workflow example of what the stages are, right? So from the dev end, any source code changes are committed to the repository, right? Any pushes are made to the repository that would trigger. And this is just a generic example. Everyone's CI/CD pipeline will expectedly look different, right? So I'm just, again, this is something that if you want to get more information on, it's better to actually have a more customized approach to this, where we can talk in the context of your workload. But here I'm going to be a little more, broad strokes about it. So once your your source code repository has been pushed with a new build, right? Then the container builder or the CI tool here is triggered, right? And the CI tool builds the Docker image. It runs unit tests on that Docker image, checks if there are any fail builds or any errors that occurred, right? If there are any errors that occur during this process, it has that option of sending a notification alert, either through Slack or some other channel. And then, of course, once the image is verified, you can push it to the GCR repository as a Docker image. And now you can actually use Spinnaker to pick up on that trigger, right? So whenever a new image is, or a new version of the image has been pushed onto the GCR repository, Spinnaker can detect that new image, and then you can create a pipeline which actually deploys that image in a canary format. So for those of you who are not familiar with canary deployments, right, that's the recommended CI/CD option, right? The recommended option for rolling out updates. So basically, if you're rolling out a new application update, right, you will make it available to say only 10% of your users, right? And then you test their feedback on it, and then accordingly you increase it to 20% and 30%, right? And while you're increasing these numbers, right, you are taking feedback from your customers on, is the functionality of my application good? Is it performing well, right? These kind of things. So if it is performing well, then you can actually roll it out to an actual uh, deployment in this case. So you can see it's deployed to Canary, functional tests are done, there's a manual approval on the functional tests, and then it's deployed to production, right? But if at all you get negative feedback, right, then you always have the option of rolling back, right? So this is the recommended deployment strategy you ought to adopt. If you ever, your only 10% of your users will get to see the newer version of the application, and if they're not satisfied with what it looks like, right, they will tell you, like you are relying on your customer feedback, you are relying on functional tests, and you're relying on even performance tests here, right? Based on that feedback, you can actually make a decision to roll out or roll back. So, like I said, Spinnaker is a hybrid CI/CD solution. This entire pipeline is meant for, it can be used for hybrid environments. So even if you have like Kubernetes environments on Google Cloud or on premises or on AWS or anywhere else, right? You can use the same tools to deploy to all these different environments. So for your source code, you have, again, cloud source repository. So it's basically your private Git repository hosted on GCP. You can easily perform Git operations, and you can sync to your existing GitHub or Bitbucket repositories. Fairly straightforward, nothing out of the box here. And then you have your container builder or your cloud builder, right? So this is the native CI tool which Google offers. It's well integrated with their other services, right? You can actually keep you can keep decently complex build pipelines. You can build container images or even non-container artifacts using this, right? You can push those builds to the GCR repository. So it's a fairly neat tool. The entire build is managed by Google, so you don't have to worry about scaling up to meet the number of. So if you have multiple concurrent pipelines running at the same time, you don't have to worry about scaling up and all that. It's entirely managed by Google. And that's a concern that you have to worry about. Like, so again, we address that by using Jenkins on GKE, but you could optionally you can also go for this, right? And then artifact management. So I was talking about GCR and it's how it actually does that vulnerability scanning, right? So again, this feature is no longer an alpha, it's GA. So you can actually see by default, right? It actually shows you once the images are built, what kind of vulnerabilities are there. You can actually click on this and click on these options and get even further details about what is the weak spot here in my application, how can I address it, right? And it even tells you the severity of each vulnerability, right? So you can see it gives you a small overview: 4 critical, 16 high, 79 medium, 17 low, 22 unknown. Right? And right now it shows you that only it works on certain OSs. This is again an older slide. Right now it's GA, and there are more images that have been incorporated into this feature. And finally, the CD part, which is Spinnaker, right? So one thing that I didn't talk about, it's not actually mentioned. This is open source tool called Optimise, right? I'll show you a bit about it here. So this is something that we've started using recently. And it's pretty cool. It basically allows you to make, it allows you to make templatized changes or patches to your Kubernetes manifest, right? So this along with Anthos config management. So Anthos config management is another tool similar to this. Despite the name, right, you can actually use Anthos config management without actually having Anthos. And what it does is it basically serves as a single source of truth for your Kubernetes policies. So if I want my dev environment to only have 2 nodes of 2 vCPU each, and I want my my dev deployment to only have like 2 replicas or 1 replica, and I want my prod environment to have 5 replicas, right? Instead of changing these in different manifest files, right? In my prod manifest and my dev manifest, I can actually keep all of this in a single customized manifest file. And I can just, these customized manifests are mapped to their environments. So every time an environment is being deployed, right, it looks at that customized file, it looks at the manifest that Optimise is providing, and accordingly it deploys. So that's a very neat tool for actually centralizing your patch management, your Kubernetes cluster management. Not cluster, I would more say pod management, actually, or container management. Right, so Spinnaker is an entirely open source tool. It's available on GCP. Both Spinnaker and Jenkins are available on the GCP marketplace. It has already a bunch of built-in best practices that are meant for deployment. It supports multiple deployment strategies. You can even use this in collaboration with Istio. So if you have like a multi-cluster environment, you can use Spinnaker for the CD, and you can use Istio, multi-cluster Istio, to actually manage the entire service mesh, right? So this is a good way of centralizing your management dashboard, right? To make sure that the every time a change is rolled out, right, it doesn't have to be rolled out from multiple different areas, and there you have the potential for multiple different errors. So basically, to reduce the human error there, right, to make the deployment as automated and smooth as possible, it's recommended to actually use some of these tips and tricks. And Spinnaker, of course, since it's open source, it has a lot of good integrations already, right? Here are some, just to list a few. And this is what the pipeline actually kind of looks like, just to give you a rough example, right? So it finds the image from the GCR repository. It's probably triggered by the image there. It starts deploying to your cluster in canary mode, right? And then it actually waits for the feedback. This is the feedback waiting process, right? If is this application performing well, can we roll it? When they say deploy prod to red black, they actually kind of mean like it's kind of like a blue green kind of deployment, right? Where you have both environments running at the same time, and before the cutover process is complete, right, with manual approval, there's actually a testing phase, right? It's a functional testing, might be even in a beta testing phase. And then eventually you tear down the canary deployment and you make it into an actual fully fledged rolling deployment. And the old version of the application is eventually deleted. Right? So this is what your standard pipeline would look like. Again, everyone's pipeline would look very different. So the most common pipeline that we see is, you have your source code repository, builds to dev are entirely automated. Then when it goes to QA and staging, and then when it goes to prod, every step of the way needs to be manually approved, right? That's the recommend, at least for prod, before it gets rolled out to prod. At a minimum you need manual approval there. So that's like what standard CI/CD looks like. So again, we can get into more details about this. The reason I didn't want to go too much in depth into this particular regard is because everyone's application will have a different kind of optimal pipeline, right? And this is something that we can actually help you out with. We've done this countless times. So we can actually tell you the best practices that you should be using just to make sure everything is centralized, organized, and clean, right? Because I've seen a lot of really messy CI/CD pipelines. I've seen source code repositories with countless branches, and people don't even know what some of the branches do, right? I'm sure some of you can relate to that. But basically, we can explain to you what the best practices are when it comes to these kind of things, right? That concludes the session for now. But just to summarize very quickly on what are we covered, right? So we talked about Kubernetes, we talked about GKE, I talked about various features available on GKE, how we can use them, right? I talked about certain security aspects of GKE, how to enable these security features, how to use least privileged nodes, etc. And then I touched base on standard CI/CD deployment for a Kubernetes environment. And this is not specific to GKE, right? You can implement this for any Kubernetes environment. I hope the session has been very insightful for all of you. I hope you have learned something new.
Thank you, Alfred and Mohit, for today's session, and thank you everyone for joining in.